All right, so today we're going deep on something a little different.
Okay.
Yeah, it's kind of like a Talk Tensors spin-off, if you will.
Oh, cool.
So we got this new academic paper, and it's all about machine learning, but specifically generative AI
Okay.
and how it's being used in transportation planning, which is,
interesting.
yeah, it's a pretty fascinating area, and we're going to kind of break it down for everyone.
Awesome.
Yeah, this paper is really interesting because it goes way beyond just theory.
Yeah.
You know, it actually gets into how these really advanced AI systems
Right.
could like totally change how we plan and manage transportation.
Mm-hmm.
Like everything from, predicting how people are going to move around
Yeah.
to even like designing the infrastructure of the future.
Wow.
It's pretty wild. And it's a really cool intersection of like two super important fields.
Yeah, you don't often see those two things together.
Right,
It's
exactly.
a cool combination.
And the potential here is just huge. Like imagine AI helping us not just like tweak existing traffic flows,
Mm-hmm.
but like actually coming up with totally new transportation networks or,
Yeah,
forecasting demand with accuracy we've never seen before.
that would be amazing.
Yeah, so our goal today is to really dig into the core of this survey paper.
Okay.
We want to figure out, why it matters so much,
Yeah.
how it builds on what's already been done,
Right.
and what new directions it might lead to.
Got it.
And, something that's really cool about this paper
Yeah.
is it's super interdisciplinary, like the authors are,
Mm-hmm.
from both computer science
Okay.
and transportation engineering backgrounds.
So it's like a real team effort.
Exactly. And it shows that they're serious about making sure
Mm-hmm.
that all these AI advancements are actually grounded in the reality of transportation problems.
I like that.
So let's jump into the paper itself.
All right, let's do it.
What's the big takeaway? What's the main framework they're presenting?
Well, at its core, this paper gives researchers and also people working in transportation like a structured way to think about using Gen AI in transportation planning. It's like a roadmap in a way.
I see.
And they do this by developing what they call a taxonomy,
A taxonomy.
which is basically a fancy way of saying a classification system
Gotcha.
that looks at this whole field from two main angles.
Okay.
So first, they categorize all the different transportation planning tasks
Mhm.
where Gen AI is starting to make a real difference.
Okay.
And then second, they lay out the specific computational techniques
Right.
that are being used in all of those tasks.
So it's kind of like a two-pronged approach.
Exactly.
So let's start with those transportation planning tasks.
Sure.
What kind of tasks are we talking about? Where is Gen AI starting to have an impact?
So they break it down into 5 main categories.
Okay.
Yeah, so the first one is descriptive tasks.
Descriptive.
Yeah, and this is where Gen AI is used to help us understand existing transportation patterns and data.
Okay, so like analyzing what's already happening.
Exactly.
Got it.
And then you have predictive tasks.
Predictive.
Yeah, things like forecasting future traffic congestion or passenger demand.
So trying to see into the future.
Exactly, that's a good way to put it.
Okay.
And then third, you've got generative tasks.
Generative.
Yeah, where the AI actually creates new transportation scenarios or even like designs.
Wow.
Yeah, you could think of it like the AI sketching out potential new bus routes or something.
So it's not just analyzing what's there, but coming up with new ideas.
Exactly, it's pretty cool.
That is very cool.
Then there's simulation tasks.
Okay.
So that's where you're using AI to model the complex interactions within the whole transportation system.
So like a virtual world of transportation.
Yeah, pretty much.
Gotcha.
And then finally, there's the explainable tasks.
Explainable, why is that important?
Well, it's all about building trust,
Okay.
So in this case, the AI helps us understand why it's recommending a particular solution.
Ah, that makes sense. So we're not just blindly following the AI's suggestions.
Exactly.
We want to know why it thinks something's a good idea.
Right.
Okay, so those are the 5 categories of transportation planning tasks.
Right.
Now, what about the computational side?
All right.
What machine learning techniques are they focusing on?
They really dive into how different Gen AI methods are being adapted for the specific challenges of transportation.
Okay.
So they talk about data preparation, which is really important because transportation data can be messy.
It's not always nice and clean.
No, it's not. You got data coming from all sorts of different sources.
That makes sense.
Then they talk about domain-specific fine-tuning.
Okay, what's that?
So that's basically taking a general AI model and making it better at dealing with transportation problems.
Okay.
And then they go into all sorts of different inference strategies.
Inference strategies.
Yeah. So that's all about how these models are actually used to produce insights.
Got it.
And they highlight some cool techniques like retrieval augmented generation.
Retrieval augmented generation.
Yeah, that's a mouthful.
It is.
But basically it means the AI can pull in relevant real-time data while it's working.
So it's not just stuck with whatever it was trained on.
Exactly.
It can adapt on the fly.
Right.
That's really cool.
Yeah, and then there's zero-shot learning.
Zero-shot learning.
Where the model can take on new transportation problems, even if it hasn't seen anything exactly like them before.
So it's like it can generalize its knowledge.
Exactly.
Wow.
Pretty powerful stuff.
So it sounds like this paper is really setting the stage for a more systematic way to use all these awesome AI tools in a really practical area.
That's a great way to put it.
Yeah, and it feels like it's coming at the right time.
Definitely.
With all the advances we're seeing in both AI and transportation tech.
Yeah, it's the perfect time for something like this.
So why is this survey so important right now?
Well, I think it addresses a really critical moment. We're seeing generative AI becoming more and more powerful all the time with amazing capabilities in lots of different areas.
Right.
And so naturally, people are starting to ask,
Yeah.
how can we use this to tackle the really tough challenges we have in transportation?
Makes sense.
And that's where the survey comes in. It's like a bridge
Okay.
between all the exciting possibilities of Gen AI
Yeah.
and the specific knowledge and needs of transportation planning.
So it's not just about the cool tech, but about how to use it effectively.
Exactly.
That's really valuable.
Yeah, and it helps to direct all the enthusiasm for these new tools in a way that's actually useful for solving real-world problems.
I like that. And you mentioned earlier that this paper is aimed at a pretty wide audience.
Yeah, it really is.
Who are they hoping to reach?
Well, they're trying to reach computer scientists.
Okay.
We're looking for new impactful applications for their AI models. And then you have transportation researchers who are looking to improve their methods.
Yeah.
And also practitioners in transportation agencies who are thinking about adopting these new technologies.
So people on the ground actually making decisions.
Exactly.
Wow.
And even policymakers.
Policymakers, really?
Yeah, they need to understand the potential of Gen AI to shape the future of transportation.
That's a broad spectrum.
It's a really ambitious paper in that sense.
Okay, so now we have a good idea of what the paper covers.
Yeah.
And why it's so relevant right now in the world of machine learning. But to really appreciate its importance, I think we need to look back a bit.
Okay.
What are the traditional approaches to transportation planning that this paper builds on?
Well, traditional transportation planning has always been focused on moving people and goods efficiently and sustainably. It's a field with a lot of history.
Makes sense.
And one of the core concepts has been this thing called the 3C planning process.
3C planning process.
Yeah, it stands for continuing, cooperative, and comprehensive.
Okay.
And it emphasizes that good planning needs to be an ongoing effort. It has to involve collaboration between different stakeholders.
Right.
And it needs to consider all parts of the transportation system.
So it's a very holistic approach.
Exactly.
And I think more recently there's been a shift towards something called a performance-based approach, right?
Yeah, absolutely.
So what is that all about?
Well, it's all about making sure that transportation investments actually lead to measurable improvements.
Okay.
So instead of just building new roads or whatever,
Right.
the focus is on how those projects will actually affect things like travel time reliability, safety for everyone, using the road's accessibility for different groups of people,
Yeah.
and even environmental impacts like emissions.
So it's very data-driven.
Exactly.
Yeah.
And that's where these advanced computational methods like machine learning can really shine.
They can help us track all those different metrics.
Exactly.
So before we had all this fancy AI, what were transportation planners using?
Well, there were a few different tools. Static regression analysis was pretty common. It's basically a way to forecast travel demand based on things like population and income.
So kind of like looking at historical trends.
Yeah, pretty much.
Okay.
And then they also use something called activity-based models.
Activity-based models, those sound familiar.
Yeah, or ABMs for short.
ABMs, okay.
And these models try to simulate the daily activities of people and figure out how those activities will lead to different travel patterns.
So it's getting a bit more sophisticated,
Definitely.
trying to model human behavior.
Exactly.
But I remember those being pretty computationally intensive.
Oh, yeah, they are.
So what's the problem there?
Well, ABMs are definitely a big step up from simpler models, but they still have trouble capturing the full complexity of today's transportation systems.
Okay.
Think about all the different ways people can get around in a city.
Right. You've got driving public transit, cycling, walking, ride sharing.
Exactly. And people are constantly making choices between all those options.
Yeah, it's a complicated system.
It is, and ABMs can struggle to keep up with all those interactions.
And that's where generative AI comes in,
Right.
with its ability to handle all that complexity.
Exactly. GenAI can process huge amounts of data, from real-time traffic sensors to GPS tracking to even social media trends.
Wow.
And it can simulate really complex travel behaviors.
So it can make those ABMs even better?
Exactly. It can make them more scalable and more realistic.
That's pretty amazing.
Yeah, it's a big leap forward.
And I'm guessing this paper highlights some of the key tasks where those traditional computational methods have been really important.
You bet.
What are they?
So they talk a lot about demand forecasting,
Okay.
which we've already touched on.
Yeah.
But they also highlight data fusion and analysis.
Data fusion and analysis.
Yeah, which is all about combining different data sources to get a more complete picture of the transportation system.
So like putting all the pieces together.
Right.
Okay.
And then, of course, there's traffic prediction.
Traffic prediction, that's a big one.
Huge. Yeah, it's essential for managing congestion and planning for future needs.
And now with Gen AI, we have a whole new set of tools to tackle these tasks.
Exactly.
So this paper talks about the evolution of AI in transportation,
Yeah.
outlining these three approaches: traditional AI-assisted and generative. Can you walk us through those?
Sure. So the traditional approach was all about the experts.
Okay.
They did everything from collecting the data to building models based on their knowledge and experience.
It was very manual.
Very manual, very expert-driven.
Okay.
Then came AI-assisted transportation planning.
Okay.
So in this phase, the experts were still setting the goals
Right.
and defining what success looked like.
Yeah.
But they started using machine learning to automate certain tasks and help them make better decisions.
Okay.
So for example, you could use algorithms to predict traffic flow based on historical data. The experts would still decide what they wanted to predict,
Right.
but the AI would handle all the data crunching and model building.
So it's like AI as a tool.
Exactly. And then we get to the generative AI approach,
Generative AI.
which is like the next level.
Okay.
Here, the experts are still providing the high-level objectives
Right.
and the criteria for validation. But the AI system takes on a much bigger role.
Okay.
It can actually implement things and even do some of the validation itself.
Wow.
Yeah, generative models can simulate these really complex transportation networks and create new scenarios without needing someone to program every single possibility.
So the AI is starting to drive the decision-making process.
Yeah, in a way that wasn't possible before.
That's pretty remarkable.
It is, it's a big shift.
So what can generative AI do that we couldn't do before?
Well, one of the big things is scenario simulation and evaluation.
Okay.
So we can now create and analyze all sorts of different future transportation scenarios.
Like what kind of scenario?
Like what happens if we implement new policy?
Okay.
Or what if autonomous vehicles become widespread? Or what are the effects of climate change on transportation?
Big picture stuff.
Exactly. And we can test all these scenarios under different conditions.
That's powerful.
It is. And then in terms of traffic prediction and just making things run smoothly,
Right.
Gen AI can combine real-time data with historical trends to optimize things like traffic signal timing and routing.
So it can actually improve how our transportation systems work in real time.
Exactly.
Wow.
It's pretty exciting.
So this evolution of AI in transportation is clearly moving towards more and more powerful and autonomous systems.
Definitely.
Okay, so now let's get to what the paper calls novel notions.
All right.
What are some of the key insights or challenges that are specific to using generative AI in transportation?
One of the most important points they make is the need for transportation-specific model adaptations.
Okay, so what do they mean by that?
Well, they're saying that if you just take a general-purpose Gen AI model, like the kind that's trained on tons of text and images from the internet, it won't necessarily work well when you apply it to transportation problems.
Why not?
Well, there are a few reasons.
Okay.
One is that transportation data sets often have biases in them.
Biases. How so?
Well, the data might not accurately represent all parts of the population,
Okay.
or it might reflect historical inequalities.
I see.
And if you're not careful, those biases can lead to unfair outcomes when you use AI.
That's a really important point.
It is another reason is that general AI models can sometimes produce outputs that don't make sense in the context of transportation.
Like what?
Like imagine an AI suggesting a route for a car
Okay.
that goes through a building or something.
Right, that wouldn't work.
Yeah, it would be nonsensical.
Okay.
And then finally, there's the cost of running these huge general purpose models.
Yeah, those can be really expensive.
They can, and a lot of transportation agencies just don't have the resources to handle that.
So you're saying we need AI that's specifically designed for transportation.
Exactly.
Okay, what's another novel notion they discuss?
They also talk about the problem of insufficient domain-specific knowledge integration.
Insufficient domain-specific knowledge integration, that's a mouthful.
It is basically what they're saying is that even though these large language models, or LLMs, have a ton of general knowledge, they often don't really understand the fundamentals of transportation. Like things like the capacity of a road network, or how people typically travel using different modes, or all the complicated rules and regulations that govern transportation.
So they don't have that common sense knowledge that a human expert would have.
Exactly.
So just giving an LM the bunch of transportation data isn't enough.
Nope, not at all.
It needs to actually understand the domain.
Right, and the paper suggests that we need to create specialized transportation data sets. And develop new training techniques that specifically incorporate transportation knowledge.
Interesting.
And maybe even build hybrid AI systems.
Hybrid systems.
Yeah, that combine the strengths of generative models with traditional transportation simulation techniques.
So taking the best of both worlds.
Exactly.
So those are some of the challenges. Now, what about future directions? What kind of future work does this paper inspire?
Well, one of the big areas is developing modular pipelines.
Modular pipelines, what are those?
So basically, it's about combining domain knowledge with Gen AI to create systems that are really good at specific transportation tasks. So for example, you might have a pipeline that's specifically designed to estimate origin-destination demand.
Origin-destination demand.
Yeah, which is basically figuring out where people are traveling to and from. Or you might have a pipeline that's focused on optimizing traffic signals.
So it's about being more targeted with how you apply Gen AI.
Right. It's not just throwing Gen AI at the problem and hoping for the best.
Yeah, that makes sense.
You need to carefully design these pipelines to incorporate both the power of AI and the specific knowledge of transportation experts.
Got it. What else?
Another important area is developing new evaluation metrics.
New evaluation metrics.
Yeah. So right now, a lot of the metrics we use to evaluate AI are kind of general purpose. But they might not be the best way to measure the real-world impact of Gen AI in transportation.
Right. So we need metrics that are specific to transportation.
Exactly.
What kind of metrics?
Well, we need metrics that look at system-level outcomes.
System-level outcomes.
Yeah, things like improvements in sustainability, efficiency, and accessibility.
So not just how well the AI performs in isolation.
Right. But how it actually affects the transportation system as a whole.
That's crucial.
It is, because ultimately we want to use AI to make things better for everyone.
Absolutely. Are there any other future extensions they mention?
Yeah. They also talk about the importance of dealing with uncertainty.
Uncertainty.
Right, because transportation systems are inherently unpredictable.
Yeah, you never know what's going to happen.
Exactly. You could have weather events, accidents, sudden changes in travel behavior.
Right.
So Gen AI models need to be able to tell us how confident they are in their predictions. And they need to be able to adapt when things don't go according to plan.
That's a tall order.
It is, but it's essential if we want to use AI safely and effectively.
And of course, there's the whole issue of real-time data.
Right.
Transportation systems generate a ton of it.
They do, and we need to figure out how to use all that data to make Gen AI even more powerful.
So it's a very active area of research.
It is. There's still a lot of work to be done.
That's exciting, though.
It is. It's a really dynamic field.
This has been a really fascinating deep dive.
Yeah, I agree.
This paper on generative AI and transportation planning is really thought-provoking.
Definitely.
And it's clear that machine learning has the potential to completely revolutionize how we think about and manage our transportation systems.
Absolutely.
It's a really exciting time to be working in this area.
It is, and this paper is a great guide. It highlights the amazing possibilities, but also the unique challenges that come with using these powerful AI techniques.
And it's important to remember that transportation has a huge impact on society.
Yeah, absolutely.
So we need to make sure that we're using AI responsibly and ethically.
Couldn't agree more.
So we've talked a lot about the big picture.
We have.
But I'm curious, what specific extension of the ideas in this paper do you see as having the most potential to really change how we experience transportation in the coming years?
That's a great question.
Yeah.
Well, building on this idea of domain-specific knowledge integration, I think we could see the development of these really sophisticated AI-powered digital twins.
Digital twins.
Yeah, so imagine a system
Okay.
that can not only model current traffic flows, but also simulate the long-term effects of things like infrastructure changes,
Okay.
policy decisions, even shifts in how people behave.
Wow.
And all of this would be powered by generative AI that's been deeply trained on both transportation principles and real-world data.
So it's like a virtual laboratory for transportation.
Exactly.
That's amazing.
Yeah, and it could allow us to plan for the future in a much more proactive and adaptive way.
That's a really compelling vision.
I think so.
So for anyone listening who wants to learn more about this rapidly evolving field,
Yeah.
we definitely encourage you to check out the survey paper we've been discussing.
Definitely.
And there's a ton of other research happening at the intersection of machine learning and transportation planning.
It's a really exciting area.
Yeah, it's a field that's full of opportunity, and it has the potential to really shape our future.
I agree. It's definitely worth keeping an eye on.
Absolutely. Thanks for joining us on this deep dive.
My pleasure.
We'll see you next time.
Sounds good.